what's up, Cliff? Hey, Roderick. Good to see you all here. I'm just gonna. My hair in my face. Oh my gosh. Part of me just wants to be like, what if I just grow my hair out for like another year? What if I just keep growing my hair out while I'm gone? So that way I will not have cut my hair since I come back to Knoxville. Like when Chelsea and I moved back to Knoxville, that's when I cut my hair. And by then my hair is just like, what if? What if? But then I'll be like the long hair guy. I'll be like, because then you don't want to cut it. Then you want to be like, no, that's my thing. I'm the long hair guy. Am I already the long hair guy? I don't know. I was looking at the responses. I need to send out the links. Let me send out the links. A day remains. So it closes tomorrow night. Let me do that right here while we're talking. Let me send out and just say, hey, everyone, just a quick reminder. Fill out the TN voice. Just a quick reminder. So I'm going to get that up and going. If you have questions, let me know. YouTube is acting weird today, so that's good. I was watching a channel and it was buffering a whole bunch, and everyone was like, yeah, YouTube's acting weird. And I was like, oh, that's not good. So let's send out an email here. Let's see what people are saying. Cliff or Roderick, you have questions, let me know. Maybe I've just been buffering this whole time. Maybe I'm just frozen, like completely frozen. Completely frozen. You never know. Did we announce that last night? Need to remind everybody to do the TN voice. So TN voice survey. Hey everyone. Just a quick reminder. The TN voice survey is about to close. This is a great way to share your views about the class. I read this along with my department head, myself, and multiple your reviews. Let me see what people are saying. I know, Roderick. I'm so sad it's almost over. How's your day going, Roderick and Cliff? I've been so quiet right now. Let's play some sad music while I'm typing out the announcement right here. I'll let you guys help with the announcement. I'll put it on the main screen. Sorry, people can about to send this out to all the classes. What do you think? What should we write? Oh, you can't see it. There you go. Now you can see it. Just quick reminder, the TN voice survey is about to close. This is a great way to share your views about the class. Your review helps guide what we improve, what your reviews help guide my teaching. So click here to take survey. There we go. Go there, click there, boom, boom. Did that work? Link options. Let's delete those spaces, make sure it doesn't break it. There we go. Let's click it, see if it goes there. Yep. Okay. I don't have any fill out. I think that's got it. And then I'll go here and go Brian at the end. There we go there. And everyone should start seeing this TN voice survey. Okay. That's being sent out to one class right there. One class has it sent. There's the TN voice survey response rates. We need to get for 320. We need to improve it. They get bonus. Here's another 201 class. Here's another 201 class. I'm doing it in the background right now. I'm copy pasting. There's a 320 class. If you're in 320, you should be seeing that. I am just like, I think we're all just tired. It's been such a busy semester, but really, as Brian's like falling asleep. Exam 3 is only chapters 14 through 19. I believe so, right? Kayla, good to see you here, Kayla. Sorry, I was sending out the announcements there. Sorry if I missed that for a second. Let's go take a look at the exam material. So let's go over to the modules. Here, I'm going to pull this up right here. And let's double check. So this sampling distribution of the means, I believe that is on this exam. Sampling distributions of the mean. Let me double think. Inferences about means. Let's go look. A great way to know what's on the exam, like I want to double check before I say anything, is to go to the assignments. Let me put chat up on the screen so I can see chat at the same time. I need a third monitor. I need a third monitor right here so I don't look down. So I'm always, here we go. Okay, here we go. Yes, look at this right here. This is a great, maybe you guys can't see these groups, but this is a great way to know what's on the exam. Also, Kayla, do not forget the business analytics, which I covered that yesterday. I can go over anything you want right now. But Kayla, the business analytics lecture is also on here. It's not a bunch to know. You know, just if you read through the slides or you pay attention to any of, if I am your instructor, or I think Kayla, I might be just, I don't know, sometimes people visit from other sections. I'm trying to see. But I know usually the blue names are like the ones who are mods are in my section. But these are the chapters right here. This is, obviously these say what they are. This is chi-squared. This is two sample means. This is, why can't I think what that chapter is? More on tests is one of these. And my brain's just like turning on, being like, burp, 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 burp. Chapter 15 quiz. Can I view it? It's going to say it's closed. It's like you can't do it. Can't do it. More on tests. And, oh, I know what it is. 15 is hypothesis testing. 16, they changed the chapters a few years ago on us, and it's still, my brain just hasn't set to them. Chapter 15 is where we do the testing, and chapter 16 is more on tests. So chapter 15 is the one about testing, and then chapter 16 is the, yay, Kayla, thank you so much, Kayla. I'm sorry I didn't recognize the name right off the bat. You know what, Kayla? Let's hear it. We're going to make Kayla mod. Kayla, I'm making you mod right there, so that way you're a mod. Usually don't do that during office hours. Ella, good to see you here. If we could do an example question, yeah, which chapter do you want to do, Ella? Or do you want me to do like an example question and not tell you what chapter it's from? Chapter 15 is hypothesis testing. Chapter 16 is more on tests. I was like, which one's which? They used to separate them out a little bit differently. So I was like, and I think it was like just a year or two ago. I've been doing this for like 10 or 11 years. You're now a mod, Kayla. I don't usually make people mods during office hours, but you came in and you asked a question like directly to the class. So I was like, I do a question and don't know what it is? Yeah, let's do that. Let's do that. I just putting a cut in the video right here. Oh, what I'm so excited for is like, so I'm teaching mini term, Ella, and I'm just gonna like, in the meantime, I'm just like, I don't know, I'm just gonna play some video games for a moment with Chelsea probably. But like, let's just stay up late one night and play video games. But she has to work. She has to get up early, so she'll be like, you're a bad influence on me asking me to play video games late at night. But I guess it's video games. Let's just play video games. She and I have a few favorite video games. So, all right, let's do this. Let's hop over to the main screen. Okay. So this is a question, a mystery question. We have no idea what it is. So let's go ahead and say this. First off, try to identify what type of question this is. So it's mystery question, example 1. Let's do it. I'm not going to tell you what to do here. UT wants to study how many visits to the TREC students take a semester. They take a sample of 100 students, and from this sample find an average visit of 8.8 with a standard deviation of 0.6. Is this unusual? 1. Calculate the test statistic. 2. Estimate the p-value. 3. Create a confidence interval using, I'm not going to tell you what this is right now because that'll partly give it away. Using let's put it here. It partly gives it away if you know, like the test would probably tell you what thing it is. I don't want to give it away quite yet. I'm trying to think what it'll be. Like I'm trying to do it in my head, and I'm like, ooh, it's gonna be close. Okay, it's probably gonna be about that. Explain the similarities between the confidence interval. Okay. Ella, do you have some ideas on this? Can you start identifying what this is first? Start identifying what this is, ideas on it, notation on it. Okay, and then wait. You are correct. It's a t-test. Great job, Ella, right there. It's a t-test. It's a one sample. It's one mean. That's how Ella identified that right there. It's t-test and t-interval. So we have here t-test, t-interval question. Because you can do, like, if you do a t-test, you can do a t-interval. Does that make sense, Ella? Like, if you do a t-test, you can then do a t-interval. Like, a t-test will test a value of the mean. A t-interval will make an interval to estimate the true value of the mean. So we can be like, let's test what this mean is, or let's make an interval that estimates what this mean is for the truth. So from this, identify any of the Ella's already, nice job, Ella. You're gonna destroy the final. I like this. That's amazing. And then you might have also, there's an additional thing down here if you want to get everything. So there's two other things down here. So there's two other things right here. Well, I guess I should have done this up here. Is the truth 10 minutes or 10 visits? I should have put it up here. Sorry. I was doing it in my head and also writing it out. So that we should put that right there. Calculate. So now there's two other things on. Well, if you want to just handle this top one first, we can get down to the t interval later. So is the truth 10 visits? So that's going to be right here because we're going to use that to do the test. So this is the sample size. It's how many we spoke to. Once we get sample size for t, we always do the degrees of freedom. Degrees of freedom are n-1 right there. Yes, it's Ella. Ella. If you are practicing well right now, everything you said there is accurate, Ella. Which I should have done that. I didn't do all the steps. Ella's doing the steps right here of writing the null and alternative. There we go. We have the sample mean of 8.8. We have the standard deviation of 0.6. And then Ella went through and wrote the null and alternative, which is going to be our first step right here. Now, when you write your null and alternative in statistical notation, the null always gets the equal sign. This one just says, is the truth this? So we're just going to use the does not equals alternative. So we don't have a cited alternative here. Really? Let me fix this so it doesn't do it again. You have to select color twice. Oh, no, it's going to make a problem. There we go. So now we have to do the does not equals alternative. We're testing mu here because mu is the true mean. And then the hypothesized value is 10 minutes. So that right there is what we call mu naught. That is the hypothesized value. And so now we just have to run the test, calculate the test statistic right here. We'll go ahead and write the equation. We'll do a different question after this. I'm sure people are probably going to really like this. A lot of people have said, can you do problems that see if we know what to do or do the steps? So you will be given this on the test. Kind of look to see where you have the notation. If you've identified the notation, you'll see right here that the notation is as follows. And I made it easy enough so I could solve it. This is equal to t with n-1 degrees of freedom. That's a subscript right there. You don't solve for it. So this is equal to oh, is it really that? Oh, you are right. Oh, wow. Yeah. You are correct. That is correct, Ella. Great job, Ella. I meant for that to be 6. Yeah, so it is negative 20. That is 100% correct. Which is going to be, okay, then that makes our life really easy in solving the rest of it. Estimate the p-value here. That can be done. What do you think the p-value is going to be, Ella? Good to see you here, Snea. If you got any questions, let me know. What do you think the p-value is going to be? Because you got negative 20. So, yeah, square root of 100. That's going to solve out on the bottom. I will do more steps on it. So this solves out right here. Calculate the t-statistic. This solves out to it should be negative 1.2. Yeah, negative 1.2 over 0.06. I was actually solving the standard error, which is the bottom part in my head while doing it. Yeah, basically 0. So that makes the p-value estimate really easy because it's ridiculously off the scale. We can view it, but it's here, Mubot. Why don't you go and show us the Mubot's going to bring up the t-applet. Mubot can talk again. I do have a small clarification. Yeah, let's put your question in the chat, and I'll do a clarification on it. You can definitely ask those things. Yeah, it's okay to ask here. Like, it's probably better to ask here because it puts it out to everybody. And if I can, like, whatever I can say, I'll say because I can clarify, but sometimes I can't be really specific. Like, I think that's one's on the quadratic trend and stuff like that. I think it's like that. But yeah, put it in the chat. So Mubot's not awake. He destroys the world when he wakes up. Wake up, Mubot. Wake up. Estimate the p-value. So it's going to look... We're doing the two-tailed alternative, and it's going to look ridiculous. It's going to be over here. Well, we're over here technically. This is where we landed. This is just as extreme because we're doing the does not equals. Negative 20 is where the t is at. And t of positive 20 is just as extreme. And there's no error. The p-value, I'm pulling up it. Awesome. Thank you, Snap. So p-value, and I'm excited. People stay on the Discord if you want. I really appreciate it. Like, Snea has been a big part of the Discord and everything. So we're going to keep trying to grow the Discord. My goal is that one day we have a big Discord where we're just keeping growing it. Second semester we've had the Discord. We're continuing to grow it. And I'm going to talk to maybe like my department and say, hey, you know, maybe we should just advertise this for every course. Like, it should be like, hey, you're in business analytics. You could be join the business analytics Discord. I think it'd be cool if we just called it the business analytics Discord, or Stat Nation, but like business analytics Discord. So like, I don't know. I'm going to talk to my department and be like, you know, maybe if everyone just said, hey, you want to join this Discord? Like, you can join up on the Discord, and I don't know. People can tell me what they think of that idea. I'm always like, Brian's a new idea machine. He just comes up with like, we should do this, we should do that. And then you have to like funnel through the ideas. So estimate the p-value right here. We've drawn it out visually. It's a two-tailed test. Why is it two-tailed? So Ella, why is it two-tailed? I think Ella should know instantaneously why it's two-tailed. Just like Ella's been just solving all the questions, which is awesome. And so why is it two-tailed, Ella? Like, how do we know it's two-tailed? Like, why am I graphing both sides of it when I find the t? Like, I'm going to go below the t and outside the t on both sides. And the reason for that, the reason it's two-tailed is because does not equals bingo. Exactly. And so just knowing those things really quickly, like getting it down that, okay, it's the does not equals. So when we go to the applet, or when we look at any pictures on the test, like, because sometimes we show you pictures, you want to find one that has the two tails graphed on it. It's 99 degrees of freedom because 100 minus 1, there's the degrees of freedom. We go to the two-tailed because, two tails is right there. It literally says two tails. And now we go and put in the t statistic of negative 20, and the p-value is 0. So it's just completely off the scale. Oh, we got it next. We'll do that next. Yeah, you got it. Created 99% confidence interval using 1.98. So this is the one I had to estimate. This is a t statistic right here. T with subscript 99 degrees of freedom. So I just didn't want to say it was a t equals that right there. And it's truthfully, so this is no longer, this is going to be the t we're using right here. So, oops, I didn't do this point. There we go. 1.984. So you would get this and then use the LSASC. Yeah, I'll do here next. So kind of, Ella, and this is basically 2. The way I envisioned it originally, it was, I was thinking how it would work. Create a confidence interval using this t right here. So we have to write out the equation. This one's a little bit quicker. So once again, we have the notation up there up top. We're going to use the equation y bar plus or minus t with n minus 1 degrees of freedom, s over square root of n, and So now we put in 8.8. Magic color change pen is back. The t is 1.984. 0.6 over square root 100. 8.8 plus or minus 1.984. And then this is times 0.06. And this whole thing right here will equal up to, this whole thing right here. And then, yeah. So that's for all intents and purposes. I just don't like rounding. I mean, I like rounding. I think so. No, I made the wrong decimal move right there. It's going to go purple now. That's correct. Oh, you might, are you using the S over square root of n, Ella? JK. A lot of people a lot of times forget to do the S over square root of n. And I was doing that in my head when I was solving. That's why I wanted to do 6, and then I was going to have 10 basically be at the edge of the interval. Did I do everything correctly right here, Ella? Check my work. And don't worry, this is just where we practice. Just check my work. I do make mistakes. So it's quite possible I could make an error on this. I made too small of a standard deviation for the problem. Yeah, and there you go. Perfect answer right there. Multiple x's. Yeah, Seth, here, let's do that. We'll talk. I'll finish this one up and then we'll talk. Can they reject 10 visits? So what do you notice about this interval right here? I used, for the standard deviation. Yeah, that'll do it. That's why you always double check your work right here, like with the S and all this. It's very easy to just put in a wrong number. And then it's just like, whoops, wrong number. I know how to do everything. I just put a wrong number in the wrong spot. So with this right here, what do you notice about this confidence interval and this test up here when we test for 10? So here was the test statistic for 10. We could check the conditions, random, 10%, nearly normal. We didn't talk about the way the distribution looks, so I really can't go through the shape of the distribution. But what do you notice about this confidence interval? And then what do you notice about our decision when it came to 10? If you don't need to visualize them all and test 2 of these, it won't. Yeah, exactly. Oh, yes, there we go. Yeah, Snea. Let's throw out some 200 points. Snea's helping out right here. I thought it was about the projects I was going to answer in a moment. You are correct. You can't visualize, it won't let you visualize multiple X's. I mean, there's some you can visualize with like interactions or some you can. It'll do the implicit lines for like 2 X's, but when you do a big model, you can't visualize it. It would be like some multi-dimensional space. And so can they reject 10 visits? Most definitely. The p-value for the test is well below 0.05. This means we reject the null that the true mean is 10 minutes and have evidence. Oh, 10 visits. Why do I keep saying minutes? Visits. And have evidence the true mean is not 10 minutes. This agrees with our interval that does not include 10 visits as a possible mean. So the interval also, we reject the null and 10 minutes won't be in there. Exactly. That's it, because since we reject the null, 10 minutes should not be in there, because when you do this is a review also of this idea, when you do a hypothesis test, so if you do a hypothesis test with a 5% alpha, it's the same result as a confidence interval with 95% confidence. So the alpha right here of 5%, which is what we generally use, if we do a 95% confidence interval, which I should have had that, 95% CI. Snea, you are awesome. So, yep, Snea helping out there with Seth. That's what I love to see. Like, let me just say this again right here. And so we'll do, Ella, we can do another question here. I'm gonna answer Snea's question, but stay tuned, Ella. We'll do another one. I think people are really gonna like these. This whole process right here of just doing a t-interval t-test, being able to identify the notation, knowing like the steps right here, solving it out. This p-value is one we can estimate. We could give you pictures on the test, or we could give you ones that you would, like if the p-values on this one were, like we wrote this as a test question, we'd put like A, this, B, this right here. Well, we make it like really obvious. C. If I were to put this on a test, it's even smaller than that's the problem. It's ridiculously small. If I were to put this as a test question, I'd say estimate the p-value, which of these is closest. So if I were to put this on a test right here, I might add some more decimals like this to make them all look similar. Like if I were to put this on a test, this is the way the test question would look. So estimate the p-value, which of these is closest. The t-statistic is ridiculous. So just by knowing when you go to the applet, which we have the applet up right here, you're off the scale. You're at a t of -20, which is just ridiculous. So you should have some idea that, t is outside of like, a t outside of 3 is ridiculous. Does that make sense right there? Thank you so much, Snea. Yeah, definitely. No, that's so awesome. Please tell, I think, and then here we'll do a serious talk, and then here we'll do Snea. Like I'm always worried that like UT is going to be like, hey, this whole online thing is just not a good idea. But to me, like we have real conversations on here. We actually like there's something to me about how are they going to these problems without using it, just like that. Like, does that make sense, Ella? So like we could show you pictures, or we could give you a T that's like very, very like close to center. Let's do that next, Ella. I'll like, how could we solve these problems without applets? So I'll do that one next right here. Like, how would you solve this without an applet? What would you guess? Yeah, and thank you so much. And everyone, thank you so much for putting in. So Snare right there. Thank you so much, everyone who puts up with if we sometimes have a little bit of problems on YouTube, where I think today we're having problems. I was watching someone's channel, it was being weird and it was buffering, and they weren't even live streaming. They were just premiering a video. So I'm like, uh-oh. But everyone's been really positive and very, like if it buffers, it buffers. I know, I think so too, Roderick. I sent out a survey to my students, and they were like, a few students were like, don't use YouTube, use Zoom. I just want all my classes to be on Zoom. And I was like, I was like, I promise I know what I'm doing on YouTube. I promise I've been doing it a while. Like, I mean, if every student said use Zoom, I'd switch to Zoom. I mean, if the naive model, I like saying naive. If the naive model was students prefer Zoom, even after experiencing YouTube, I would switch. Don't change. Thank you so much. How is our completion percentage? For one class, we got it. Here, we'll do that, and then we'll switch to Snae's question right here. Let's hop over there. So for one class, we got it. The other class, we gotta pick up the pace. I sent out a reminder, so I'll keep updating on this. Another person did it. Bron sent out a 43. I'm really happy at those 43s. This is my asynchronous class, and they're just not doing it. But I'm really happy at that 43%. Thank you, this Stat 201 section. I've never had more engagement. Wow, that's awesome. Well, thank you so much, Snea. And what I do when I talk to other instructors is I tell them buy a second monitor and put the chat there and encourage students to chat. My biggest advice to teachers has been you need to be interacting with students. Like from day one, I'll bring up the presentation. I just gave a presentation at the faculty. Where is it? Brian Studio. Is this it? Yeah, wait. Yeah. This is my presentation right here. Oh, no! And then we're going to talk about the... Oh, what? Oh, I have to bring this up. What is going on? This one's weird. Yeah, we'll just do it normal. Oh, let's do it. Good thing things break at the end of the semester. That's one right there. That's weird. So I go through and talk through... I went through this with students, like, have fun. It doesn't have the pressure of having your camera. Yeah, I think so, Ella, too. I think a lot of students don't like it. Roger, I should do something if we get 100%. No. I got to remember my pitfalls. It becomes a witch hunt if I put it to 100%. I've done that. And I literally had students like calling students and contacting students and being like, did you do it? I want you to show me you did it. It became a witch hunt with other students, and it seemed not positive. So I've learned not to put it to 100%. So yeah, I'm gonna do Snae's question right here. Let's do Snae's question. So I got to remember the things I learned from teaching is like 100% goals are not good, because then people start searching out that person who didn't do it. It's really bad when I'm like, yeah, there's one person who hasn't done it. And everyone's like, who hasn't done it? Yeah, exactly, Snea. That's the thing is like, and thank you so much, everyone who's answered questions and been wrong, because I want you to put yes or no in the chat if you've answered something in this class and been wrong. Like you're watching right now, Ella, Snea, Roderick, Seth, if you're still watching, Cliff, you're still here. If you put something in the chat and been wrong, and then you're just like, whatever. Definitely Seth says, all the time, Ella says. I bet you, people who watch these videos in the future, who watch these and use these to review, they see you in the chat, and I bet you they're thinking, wow, they really know it. But you would be like, no, I get questions wrong all the time. I make mistakes. That's why I keep answering. Mubot's going to give everyone 100 points right here. That's the goal, is that you're willing to step out and put wrong answers out there. See, now I want to play the video. I've got a video of my students like saying the things they like about this class. And that's one of the things someone said in their interview. It was Andrew who swings by. Andrew Wind is the best. He's got a quote in here. The literal quote from Mubot, Andrew Wind is the best. Andrew Wind said at one point, I think it's like quote 32. Oh, here, I can just search. There it is, quote 39. So Andrew comes by, and he'll usually put quote 39 in the chat. So we gave him his own quote. Andrew Wind is the best. So Mubak can say that. We also have my real name is Andrew too. And I like these things right here where people can make their quotes and have their quotes and people remember it. Because one student told me, they're like, oh, I can't believe I have a quote for the class. And I was like, well, it's just a fun thing. And they're like, it's so cool. They were like, I love it. That, you know, I have this memory and people can put this quote in. But let's handle Sneha's question. Let's do this. Oh. And thank you so much for all the positivity, everyone. That makes my day. But Sneha's question was, when the assignment says, oh wait, that was Seth, and Sneha answered that. Okay, so on number 10, it says we need to create a linear, quadratic, cuboid trend for models with both predictors. Since one of the predictors is categorical, we can't use the polynomial to transform the quant. Exactly, Sneha, you're 100% right. You're 100% right. Let's kind of show some stuff right here. Let's go ahead. If you are using, like, let's say you have a model trying to predict, so this is a huge hint right here, like huge hint for the take-home help. Put this in the video. So let's go ahead and make a model predicting. I've got here survey 10, classic survey 10. That's like everything is what it says it is. I'm gonna make a model predicting GPA. I'm gonna do it from gender, and I'm gonna do it from height. Now GPA not found. Oh yeah, data survey 10. I'm getting lazy when I put attach on there. Okay, there we go. So summary. There we go. There's the AIC of the model. I coded some for that question, but I don't know if I got it right. I think you'll know after this. I think you'll know. I think you'll have a really good idea. So if you go to gender, you can put the poly command around. Let's just see what happens. It shouldn't do anything good. It shouldn't work. Let's find out. Yeah, it doesn't like it. That's what I thought. It's like, no. It says you cannot do that. Reason, because, like, what is male squared? You're trying to square male. That just doesn't square. But you can go over here to height, and you can put a poly around height, and then the degree to which the polynomial you want to bring it to. And now, you look inside of here, and it does carry through model hierarchy, which we do want, and we get a new AIC of 1323.159, and the first AIC was 1321. So which model is better right now, the 1321 or the 1323? Yep. So if you're seeing, I'm not saying you're right, but here's maybe some advice. Like, if you notice, this is using multiple regression stuff we learned earlier. It's including the AIC, which we just talked about. So I'm not saying, I mean, I think, does this kind of, yeah, and 1321 is better. And they're pretty similar, correct, and that's good review for the final. They're pretty similar because they're within 2, like if you were to compare these. But so I wouldn't use the poly trend right here. If anyone's wondering, like, what would you learn from this? I would say, you know, the difference between them is less than 2. They're virtually identical. I'd go with the smaller model. It seems like polynomial trends here are not useful. And we could go to the third order. Why not, right? I wouldn't store them all over each other. I'd call this model 3 most likely. I just was going quickly and writing them all on top of each other. If I was doing this as a project or something, I would start doing, ooh. Why did Brian say ooh for this? Why was he like, oh no? And you can also see it in this right here. Seeing that right there kind of means they're garbage. Yep. And so noticing this right here, and we probably noticed it in the R-squared adjusted also. The R-squared adjusted here is 2.8. The R-squared adjusted here is 2.8. 2.9. 2.9. This is that's the poly 2. Okay. Oh, the R-squared adjusted is going down. So the R-squared adjusted went from 3% to 2.9% to 2.8%. The new polynomial trends are not significant in the model. I mean, everything in the AIC is going up. Everything right here is pointing in what direction, Sneha? Like, is the polynomial trend a good idea? Because look at what I should do is I should make a table. Let's make a table of these. I'm just going to do it off the estimates right here. So let's go with R-squared adjusted. R-squared adjusted went 0.03 to 0.29 to 0.028. The AIC went in order of 1321 to 1323 to 1325. The order right here. This is, and then the order goes 1, 2, 3. The R squared 13.3. Here I can just do an R squared. That's close enough. The R squared is going to go up each time. The R squared has to go up if you're including new variables that have estimates of coefficients. So the R squared is going to be something like this right here. This is not a bad test question, because this just screams something to me. Okay, let's make this into a... I usually make data frames for my stuff. I just like order, R squared adjusted. Like, I like this as a test question because I think it... There we go. Okay, cool. Okay. So, I think right here. When inputting... Let me see test question, then we'll go to... Okay. When inputting the p-value on the test for significance of the predictor, which value do we use if multiple variances on the same variable come up? Seth, that's a really good question. And sometimes, here's my tip for that one, so listen carefully. Sometimes you need to wrap everything up and toss it all out of the model at the same time. So I'm not going to say exactly what to do on that one, because a lot of people have been asking that one. I've been saying, like, maybe sometimes you need to figure out a way to take everything out and compare a model with more in it to a model with less in it to see if that variable is having an impact. Does that make sense, Seth? So I'm trying to allude to something like that maybe will be a tip, like to be like, sometimes you have to like take the whole thing out and be like, what does that whole variable do as a whole? Not like the parts of it, but what does the variable as a whole do? Like if you can just take everything out at once and then look at a model comparing without that variable to with it. That's pretty much the answer. I don't want to do it like directly on the screen. But does that make sense? Because it's hard for me to like, I don't know. I try to like keep all the hints in line with what I've been saying to people, because that's been a big one people have been messaging me on Discord about. It's been a big one that a lot of people have been saying, like, wait a minute, this is not showing what I wanted to show. And it's like, yeah, maybe there's an additional step. It's a good question right there, Seth. That's a really good question. What's up, Brendan? That's so awesome. And Snay is like, I think I know what you're talking about right there. I think I know what you're talking about, Brendan. That's awesome. I will see you in class. Yep, somehow you're going to have to, so think about that and look over the notes and be like, how can I compare a model with the variable to a model without the variable? How can I drop that one variable out of the model? That's some pretty big hints right there. Hopefully you're cleaning on some wording right there to be like, how can I drop that one out of the model? So big hints right there, Seth, if you catch on. Anyways. And I think Snay is pointing out how this one works right here. AIC continues to increase, so the penalty term is costing more than the benefit of explaining the model for better. Exactly. And what I you caught on, right, Snay? I think Snay gets it. Snay knows what I'm talking about right there. And so this right here, if people were to look at this, I could see this being a multiple choice question on the test. I literally might even screenshot this later. I might come back and screenshot this. You're welcome, Seth. I think Seth figured it out. Seth's like, oh, wait a minute. I know something Brad's talking about here. Thank you, Seth. I have a hard time not... I think if you get it, like to someone who's not taking this class, they'd be like, what the heck are you talking about? And I'd be like... But if you've been following along, it should make sense. So... Please look through the notes. If you don't know what I'm talking about, look through, start catching on to the hints right there. If I made this a multiple choice question test, then we're going to, if Ella, if you're still here, we'll keep doing. The wrong answer would be something like, we should use order number 3 because the R squared increases. So it's hard to write more wrong answers on this. If you put 2 answers right on here, there's 2 indications of don't use the higher order models. The first indication is the R squared adjusted is going down. That's one indication. The other indication is the AIC is going up. So I guess the second wrong answer would be we should use the third. Like if I'm going to write wrong answers, here's a wrong answer. Use model 3 because AIC is the highest. And then I could put a trick right here. However, all models, no. Yeah, I'd probably leave it at that. So that would be a wrong answer right there. So there's one wrong answer right there. That's like if I'm going to write multiple choice on this, don't use R squared in multiple regression unless you calculate VIF cutoff. It's exactly. And well, yeah, and so yes, correct, Snea, 100% correct, Snea. You're right. If we're going to calculate the VIF cutoff, which this should not have multiclinearity. Oh, it's cracking me up right there. And so then a second wrong answer would be is use model 3 because R squared is the highest. And so Ella should know about R squared, percent of variation Y explained by the variation in X. But so Ella, we have this thing in multiple regression called R squared adjusted, which it's adjusted for variables in the model. Like if you have a ton of variables, R squared will go up because X is explained. So R squared adjusted is a penalized R squared. And what else has a penalty term? We were just talking about this yesterday. AIC also has penalty terms for how many variables in the model. So both of these will not always get better. So they have penalty terms so that way models with more variables don't just do better. The right answer would be use model 1. And then because, what would I say here? I'm trying to think. R squared is the lowest. There we go. That's a wrong answer. Use model 1 because AIC is lowest. There we go. Okay. So there's the right answer would be, hey, Elizabeth, good to see you here. Happy last day of class. Thank you so much. So use model 1 because AIC is the lowest. So this right here would be the right answer, Snea. And those are my trick answers right there, like the ones I'm trying to be like, use model 3 because AIC is the highest. No, you want lower AICs. Use model 3 because R squared is the highest. R squared is going to be because of multiple regression. You want to use R squared adjusted. So none of these even mention R squared adjusted. So that's kind of a clue right there is like if you're doing a multiple regression, you want to use R squared adjusted. So I wouldn't even look at these R squared ones. I'd be like, okay, maybe I should judge it by AIC, which is how close our model is to the truth. And you want our AIC to be the lowest. So that one right there just jumps out as the right answer. I literally might put this on the test. Yep. We could do that today. Yeah, we could do that today, Snea. Which I guess we have class here in 25 minutes. I should not drink a third cup of coffee. I should not drink. I was watching that guy's video of the doctor guy on YouTube who's like, an athlete took 8 cups of pre-workout supplement. This is what happened to his brain. It's like, RC is a 22-year-old TikToker who likes to make videos. I don't know. I love his videos. They crack me up. I almost did it in an hour, but wait, is it an hour? What time do we have class? Officer, yeah, I think you're right. We have class at 2:10 your time. I don't even know time. I need to sleep. Don't I promise. Oh man, I was posting on UTK Reddit last night at 2 a.m. I was like, people were like, Brian, do you sleep? I don't know. We'll hop over here and we'll get serious. Ella, let me know if you have any questions. Ella, do you want to do another question? I think everyone's right. 250. Oh, that's what it is. You're right. You would think I'd have learned my schedule. I've got on my phone. Look at my new phone case. Beautiful. So my fiance got an iPhone SE, and she didn't like the OtterBox. So we actually got her Casetify box. Yeah, let's do another one here, Ella. So we got her a Casetify box. Here's my old iPhone SE. I think it's still getting messages and stuff. So that's my old iPhone SE, and then this is my iPhone SE 2020. It's so funny. People saw me with this phone on campus, and they're like, Brian, you got an old phone. And I was like, no, it's the iPhone SE. And they're like, it's 3 years old. And I was like, and it's now 5 years old or so, because I think it came out in 2016 or so. But then I got the iPhone SE 2020 because it was cheap. And I was like, hey, I like very, very cheap phones. I don't know. It's not cheap, but it was less price. So I'm very happy with the iPhone SE right now. And I've got a beautiful pink and purple case. OtterBox, I can just throw it across the room. Let's do that. Let's do a question right here, and let's stop learning about Brian's phone. I look over and I'm like, that's my fiance's phone. I'm like, no, that's my phone. So here we go. Let's do another question. It's just us having fun here. Let's do it. Let's see if I can trick everybody. Okay, so with this question right here, let's go ahead and see. Okay. I'm going to need help from the start of this question so I'm going to write out this question from the start. We're going to kind of do a tools and techniques aspect of it to start. Then I'm going to come up with the data. So Ella, help out right here, because it's going to be like a tools and techniques to start where you have to figure out what to do. And then I'm going to make the data to do the rest of it as I get the hiccups. Okay. So Brian wants to investigate if students are more likely to own a pet if they live on or off campus. Okay, so step 1, what test are we doing? Step 2, conditions. We'll do conditions here. Step 3, write out null and alternative. That should technically be step 2. We'll call this step 0 because we're going to kind of do it in order. Step 1 is write out null and alternative. Step 2 is conditions and find test statistic. So in this step right here, we will do expected. It's not saying this on there. Cell. Don't look at this. Don't look at this. Careful. So Brian wants to investigate if students are more likely to own a pet if they live on campus. So what do you notice right here, Ella? Oh, so I guess it could technically be, Ella, you could be right. Let me fix this. He will collect data on if a student lives on campus. Yes/no. He will also I think I see what you saw, Ella, and you are correct. Yeah, it does depend on the data because there's a different way to do it. I could set this up differently. If I wrote this question in a way that I said, Brian, I could do something like this. Brian wants to see if students who live off campus are more likely to own pets. He finds out that, or let's say 10% of on-campus students have a pet. Is the proportion of students who own a pet off campus higher than this? So now this is a 1 proportion. So this right here is going to be the null hypothesis is that the proportion of students off campus who own a pet is this. And the alternative hypothesis is going to be the proportion of students who own a pet is this. And I think that's what you're seeing right there. Good to see you here, Caroline. Yeah, now Ellie, you see the switch. So I could do this right here, writing it out as a 1 proportion, like, because proportions is categorical. So you were on the right track with that. And I maybe didn't make it clear that I'm going to collect 2 variables, which now, as Ella is seeing right here, okay, it's 2. When you say smaller model, doesn't mean the model with the no interaction. Yeah. It's naive is the smallest. So all the comparisons right there, Seth, for the assignment, all the comparisons. Thanks so much, Caroline. So, so what test are we doing? We are doing the chi-squared test of independence. And we know this because there are 2 categorical variables. This thus meets the count data condition. So when we get to the conditions here, the count data condition is that both variables are categorical. So categorical data is how we meet the two categorical variables is how we meet the count data condition. So write out the null and alternative. Okay. So what is the null? Just, you should know a classic word we use right here. A classic word we use is going to be what between the 2 things. I'll write out the format of it. Are we focusing on the independent chi-squared? Yeah, this is it. We're doing kind of just some tests right here. So we do x is independent of y, and make sure to write out the full thing. And then x is not independent of y. So when we do this, we would say owning a pet is independent of living off campus. And then we can just copy paste right here. And we can go not. Living on or off campus is independent. Yeah, and that's perfectly fine. Either which way is fine. I'd be like, yep. If I was grading that by hand, I'd be like, perfect. If you looked, we just switched what x and y are. And truthfully, Ella, Uh, I'm actually just going to copy paste what Ella put right here because I think Ella's is actually right because we're trying to understand if people own a pet and we're seeing. So Ella, he's got everyone another 100 points. I agree more with Ella than the way I wrote it because if we talk about X being the first thing, then we would have right here living on or off campus is the X, what explains if people own a pet. So I agree more with Ella than I do Brian. Brian, you gotta get your head in the game. Gotta get your head in the game. What you doing, man? So I agree more with this way right here. And whoop, just barely made it. So it's fine either way, technically. Because when we do the mathematics, it'll work the same way. Like the equations don't care if we have the X or Y in one spot, but in interpretation, which does matter, would imply that if we're saying X is independent of Y, we would say living on or off campus would not give us information about someone owning a pet, but then the alternative is that living on or off campus is associated with owning a pet. Good to see you here, Mackenzie. So conditions and find test statistic. Condition 1, random. We should do a Batman question.
It's not the question you deserve. It's the one you need.
What do people think of that? Do people like that, or like, are you like, it's cringe, Brian? It's cringe. Don't use that anymore. Let me look at the properties on it. Was it too quiet? It's Brian's random moment right there after the randomness. It should be loud enough. I know I've got a bunch of things I don't use all the time. I've got like an extra credit button. I just give out extra credit too much. So like I never hit the extra credit button. What else do I have that I never hit? You really rarely see me hit my rarely hit this button.
Know your variable types.
Stat Tool 1 sees that a lot. The shark start. I was going to say Puppet Shark. It's all random, but it's great. Thank you so much. Yeah, there's so many different things I have, and they're all available to me at the click of a button down here. Like all the different music I use, Mewbots. Mewbots on this screen now. He can appear over here. So we brought him over here to this reality. Thank you so much, Roderick. I'm glad people like it. And this all takes a lot of time to set up. Like I don't use the sound effects. I need to fix this. They're all really quiet. Like, wow, that's so quiet. You can barely hear it. So I need to fix all that. My openings, the closings, the timers I use when I'm like 30-second timer, the effects I use. Yeah. Oh, Dan, we got so much new stuff. My Stream Deck XL has been a huge help. So like, it's a huge help having this to be able to do all these different things. That may be my new favorite one, the variable types. Oh, Elizabeth, that's awesome. Yeah, that's a play on know your know your types of meat. They did so many different things. I can't even think. It was a Dave Letterman skit that they did, and then Jason comes in at the end just so you can hear it one more time right here, and then we'll get serious again.
Know your variable types.
So we use that at the start of 201 when I'm like quizzing variables. So I'm like, hey, everyone, it's time to play Know Your Variable Types. Any new sound effects? Oh, we got Mewbot talking.
I am Mewbot. I am Mewbot.
And then I accidentally put in, what's over here?
The test isn't until Tuesday, so you can wait to study until Tuesday morning.
We did that earlier this semester. And then, of course, we have the classic. Oh, wait, let's get it going. Here, we'll get, everyone's watching this. They're like, Brian, get serious, man. Wow. Final, yeah, Colin, I saw you messaged. Dude, great job with Disney and everything. Sorry I didn't message back. Everything's been so busy. But Colin, congratulations. Colin, especially since you're saying it, is interviewing with Disney right now. Former student Colin, who was in, right before we switched to majorly being online, Colin has had some in-person, some online classes with me. Colin, thank you so much for saying goodbye. Everyone give Colin some shout-outs right there, interviewing with Disney on Monday. I know, and Colin's a huge fan of Disney. Colin, we were talking about Disney yesterday with the business analytics. But give Colin some shout outs right there because, you know, we're excited for like all the vols. Sorry, I didn't message back. It's like sometimes I'll be like teaching and then I'll see it and then I'll be like, I'll wait and then I'll forget and I'll be eating dinner. I'm like, oh, I forgot. Sorry. I'm sorry. Off campus. It's okay. Colin took the class. The last semester I taught it hybrid. Oh no, you're fine. Thank you for commenting on the thing on LinkedIn about the because we did the Star Wars battle. No, it's own pet. There we go. So let's go right here. There we go. I know, Snea. Thank you so much. Throwing some positivity. I'm excited, and Colin's also. Colin, I think it is what it is. Colin, are the pictures are you still on the signs around campus? Colin has the bow tie, and but I can't remember if it's just I don't know. I walk around like it's Colin right there. I don't know. It made me smile when I work on campus, but that's a year ago. That's a year ago. I don't know if they took them down. They shouldn't. They might have because I don't know if they got like older, but like the you sure am? Heck yeah, that's awesome. Love hearing that. Yeah, and that's what I like to hear is, I don't know. This is nice. There we go. Okay, let's take a look at this data. Does someone living on or off campus explain if they own a pet? There we go. Here we go. What do you notice about this right here instantaneously? What do you notice about this here instantaneously? Got a little sidetracked. Had a little fun. What do you notice about this right here about living on or off campus and owning a pet? Like, look at those who live off campus. Look at this. Look at this. Thank you, Colin. Have a great rest of your week, too. Oh, and I also got a new phone call on that. I was talking about that earlier. It's in my fiance's old case. There's a difference right here. And it looks like people off campus are more likely to own a pet. Let's go right here to some of the questions and see if we can calculate things like the expected right here. Okay, I'm going to take this so we can calculate some expected and a cell chi-squared by hand. So let's go back to here. Got very distracted. Okay, conditions were random, 10%. Then we have expected cell counts need to be greater than 5. So which one would you like to calculate the expected cell count for? Owning a pet, what? And then off campus, on campus, what? One of these is the smallest expected cell count, and which one would you like to calculate it for? Which I think I can figure it out. I think I know what the expected cell count will be. Pretty much 50-50 for on. Yeah, exactly. A big difference when we get to on campus, exactly. Because when you go to, exactly. Great job there, Carolyn. Yep. Owning a pet, yes. And we're just going to do one expected cell count right here, see if it passes the condition. And this is how you calculate expected cell counts, is you need to cross them like this. And we're doing the smallest expected cell count to see if it's greater than. So this is the formula for expected cell count, is row total times column total over grand total. And that is equal to the expected cell count right there. So row total times column total over grand total. So 110 times 60 over 220. There we go, 30. And you might be wondering, how did I figure that out? I said 30 a moment ago. It's because half of the students are this, and then you can just take half of that. So because if you divide 110 by 220, you get 1/2, and then you can times it by that. So it's just kind of doing it a little bit quickly in my head right there. So there are 30 right here. This passes expected cell count of 5. The last condition right here is count data. Let's just show all the conditions. I want to show you all the conditions. Oh, perfect. Did someone? I might have posted these recently. All the conditions. Every single condition. Someone might be watching this in the future. I hope this helps out. Here's all the conditions right here. And we're doing the chi-squared, which is the one in orange right there. So the chi-squared test of independence has the conditions random, 10%. Then we get to expected cell count, which they need to be all greater than 5, which we just checked. And then count data. So we know that this has an expected cell count of 30. Let's go ahead and show that over here in jump. So the expected cell count of 30 right here is right here. It's also 30 up here. And so go ahead, Ella, see if you can solve, since we know that this has an expected cell count of 30, go ahead and solve out the cell chi-squared. So the cell chi-squared is going to be the observed minus the expected, and then we square it, and then we get the expected. So go ahead and solve the divide by the expected. So this is a cell chi-squared, which is just kind of like how unusual the cell is. So I'm trying to figure out in my head, Okay, that's 400. 400 divided by 30. So that should be 13.3333. Is anyone else getting 13.3333333333? Is anyone else getting 13.33333333? That's what we should be getting right here. We'll see right here. So the observed is 10. Yep. There we go. This is this. This or this. And so we get here 20 squared over 30, which is, so that whole thing right there is 13.33333333. There we go. Cool. So we can also just do this and jump right here to check our work, and we can find out each of these cell chi-squareds. One away. And the cell chi-squared right here, we're saying is 13.3333. It'll also be that for this one too. So cell chi-squared, 13.333333. We got that right there. And then Ella, can you tell me the chi-squared test statistic now? So Ella, take a moment on the screen and tell me the chi-squared test statistic. So now calculate the chi-squared test statistic from this, which is the next step if you're doing it all by hand. So calculate the chi-squared test statistic. To get the chi-squared test statistic, while people are solving it right here. So to get the chi-squared test statistic, what do? I think that's correct. Yes. You are correct. To get the chi-squared test statistic, sure went. Oh my god. Okay, we'll do it in a page. Okay. To get the chi-squared test statistic, you just sum up all the cell chi-squareds. So you just add these up right here. So this is 10 and this is 26. That's 36. And so then the last thing, Ella, we need to do is find and type the two letters. If we're going to plot that on the chi-squared distribution, which let's have Mubot bring this up. If we're going to plot that, we need to know the what for this. You'd say, Brian, this is a 2 by 2. Yeah, Ella's already put in the degrees of freedom right there. So we would say, Brian, this is a 2 by 2. And when we say it's a 2 by 2, we mean there's two answers to each question. That's what a 2 by 2 means. To do the degrees of freedom, you drop it by 1. You say 2 by 2, 2 by 2. I was doing some pinky up right there. 2 by 2, drop by 1, 1 times 1, 1 degree of freedom. So we're going to go to the chi-squared applet right here. We're going to put in 1 degree of freedom. We're going to put in 36.66666. There we go. It's off the scale. This one we would not have you estimate the p-value. Would probably show you graphics on just because chi-squared's a different shape looking one. It's usually right skew. And so this p-value right here means we reject the null. So I think we've done it. I think we've kind of thoroughly, I think we answered all the questions right here I had. The conditions, and then we would reject the null. Is this making sense here, Ella, on how to do the chi-squared test of independence? We would reject the null, and we would say we have evidence, and we can see all the results right here. It does it all in jump for us. There's the chi-squared test statistic. Here's the p-value it calculates for us. But we figured out the chi-squared by summing up all the cell chi-squareds. That's, remember, the Pearson has your p-value. So the Pearson is the chi-squared test statistic. Yeah. I feel like this chapter is easier at times. Like I've always said, this is what I feel like is an easier chapter when you're like, okay, you just have to know the formulas for that, the formula for that. And then, I mean, and we give it to you on the test. We give you the formulas. And then you have to know that this is the sum of all the cell chi-squareds. We then take this number right here. Wait, can we go over at the p-value and jump with the... Yeah, let's do that here. Let's do that. I almost do that. Okay. Stretching right there. Okay, here we go. I'm going to get some awake chocolate between office hours. Yeah, so, and we won't ever give any T tables. Oh yeah, how to read. Okay, let me get some jump output. Let's go over how to read. I'm going to make a question here while we're talking. Just okay. Analyze. Okay. Let's see right here. Points. Good to see you here, Kirsten. Let's give another 100 points. Kirsten just leading the way. Great job, Kirsten. Amazing points. Let's look at here at weather, explaining the total demand. Okay, awesome. I'm making a question as we're speaking right now. Nah, I can't do that. Okay, let me... The p-values were not... I'm going to do a subset. 2 seconds, I'm making a question. Okay, this should give results that are viewable. Like, that would be interesting. Weather, total demand. Okay, good. So let's review how to understand this output right here. I'm going to blank out everything. You can't see it yet. Hey, what's up? I love giving out points. I love points. Love all the points. This is a bad parody song. There should be like a video like every reference Stat1 has ever made. It'd be a bunch of ridiculous references. I'm currently blanking out information. Yeah. So we are going to try to solve it. Just so you can't see it yet. Ooh, that's a hard one. Sure. Okay. Got everything blanked out. Last question, I think. To check the conditions, just use check regression, then p-values. Oh, no. P-value less than 0.05 is a bad thing. That means we fail the conditions, Seth. Does that make sense right there, Seth? For when we check conditions, low p-values is a bad thing, Seth. Thank you for asking, Seth. Low p-values are bad things when checking conditions because the null for a condition is that we pass, the alternatives that we fail. So when you have a low p-value for a condition, that means evidence that the condition fails. Does that make sense, Seth? When you have a low p-value for a condition, that's evidence that the condition fails. So Roger right there up to the math stats wizard. Awesome. There's another level beyond us. There's like 2 more levels. We made some crazy levels. Let's hop in here. We got the question ready, Ella. Let's do this. Here we go. No worries, Seth. That's what we just asked. You got it. You just asked, say, is this the way it is? And then you know. Ella's getting up there too, about to get to the next level. Great job. So here we are with the difference. Okay, so the T ratio here, Ella. Not really two. I think you're talking about the test right there, Seth. There's 2 different tests for the logistic regression. Just 2 different statisticians made up 2 different tests. It's not really conditions. It's like asking if the logistics fit is a good fit. I know, right? I love it. I love that people have been here. It's just crazy to think like you can be like, yeah, I've been in this classroom for 62 hours. It's awesome. Here, wait, let me hop back before we do this right here. So just on Snea's and Seth's, I just want to make sure people see this directly right here. On Snea's and Seth's question, it's better if they're both above 0.05 Snea. Like that's the best case scenario. But if one of them is below, it's like, this is not great. If both of them are below, that's a problem. And it kind of depends on how far they're below. Because what do we know about all models? Which, like, if one of them is a little bit lower, like, whatever. You know, all models are this. What do we know about every single model we will make for statistics? Every single model we make for statistics will be this. Like, it's just by virtue of the way it works. Famous quote, all models are this. Which is, one time someone wrote on the test, why do we have to memorize quotes? Because I had a quote for them to fill out, and they're like, why do we have to memorize quotes? It's like, because it's majorly important for us to know. We need to know that this is true. Like, all models are this. It's kind of like, it's like, imagine this. So we should know that all models are wrong. And so to Snea's, all models are wrong. All models are bad. Yeah, kind of along that point right there. All models are wrong. Like we won't have the true model. And imagine if you had a friend saying you should invest your money in Dogecoin, and you had a friend saying you should not do it. What would you do then? I mean, you might lean on your own understanding, and if you have a friend saying do it, and you have a friend saying don't do it, don't worry. So does that make sense? Like you have a friend saying like you should use this model, and you have another friend saying you should not use this model. And you're like, oh no, they're giving me conflicting advice right here. One friend says it's okay, and then I figured, oh, that's too funny, Rich Roger right there. So when you look at the 2 tests, it's just 2 statisticians who are your friends apparently who are telling you their advice on whether or not you should use the model. Does that make sense? Like this is just 2 separate people being like one saying you should use it, one saying you should not use it, or sometimes they both say good. If they both say bad, that's, oh. If 2 of your friends are like, don't do it, you're like, okay, both my friends are telling me I shouldn't do this. Maybe there's a big problem here. If one of your friends tells you no, you're like, It gives you pause. If both of your friends tell you yes, you're like, okay, we're good. Does that make sense, Snea and Seth and Roderick? Like how to look at the test for if the model is a reasonable reflection of reality, if the sigmoidal fit's a good fit. We're talking about the logistic model here and if it's a good fit. So I feel like sometimes these segments I don't usually mark them in the video, and so maybe no one watches these. I should start marking these. So people will never know that we talked about the check regression for logistic right here. And then Ella, we're gonna do your question right here. Does that make sense, Snea, Roderick, and Seth? Like the check regressions are telling us whether or not our models are a good fit. Like should we be using these? And if they're both saying yes, that's great. If they both say no, uh-oh. If one says yes, one says no, it's like, I don't know. It's kind of your own judgment call at that point. So it's your own judgment call. You know what I really like, Snea? I like that you like when you had something a little bit, you laughed. I love that. I love people's like, I love that people are like people were mentioning earlier. It's like, you know, we're just here to practice. Okay, if there was a question on that, would we just say it depends, or we calculate the different? It really would come down to other factors. Like, so if I wrote a test question on this, like, here's how it would look. Okay, so if you are just jumping in this part of the video, check out the earlier part where we were talking about p-values for the check regression. And if you saw a p-value for the check regression for logistic where one was this and the other was this, here's your choices. So here's your p-values. And choice A would be something like, don't use the model since one check regression failed. Use the model since one check regression passed. So I was going to put something else on there, but I think this is about this, and this might be too easy of a question. It's so funny. I'm trying to remember the name of the analysis, but there's an analysis. So if the p-values here are conflicting, I would say look at additional metrics since one model failed. We're not going to use it immediately. We're not going to not use it immediately. But yeah, so this should shout to you, see like, it gives you pause. Like you're like, well, one of those is bad. And the one that we're talking about failed, just to be clear so everyone knows, is this is the one that fails. That's what it means to fail a check regression, is to have a p-value below 0.05. This one passes the condition that the sigmoidal fit. Yeah, and I thought it would help to see this right here. So I'd look at additional metrics. It gives you pause. You're like, oh, that's not good. But if you were to have something like, you know, to change up the question, if you had something like this right here, you know, at this point, what might be an answer to this right here, which if I don't put the X's, it's a little less clear. So this is not good. So if you saw p-values like this on your logistic fit, this is when your data might look something like, the true data might look something like this right here. And you're trying to fit the logistic model, which might go something like this through the data. So the logistic model is going to do this right here. So it would be like us checking the sample size and plots. So because we don't have plots for this one, you might check just to see how good your model is, like how well it does. So I would probably look at things like my misclassification rate. So for logistic, you might look at your misclassification rate to see if your model's really, so for additional metrics to the last one, I'd look at misclassification rate. I'd look at AIC. But I would be like, I really want something else to sell me on this model. Does that make sense? Like I want a good reason to use this model if it's going to have a little bit of problems with the fit. This one I'm super worried about, and it's probably due to the data having a what nature. This is the data right here. This is the model I'm trying to fit over it. And the data looks to have a what sort of nature, especially over here. That's where it really shows clear. So there won't be an R-square adjusted for this because it's logistic. We only have misclassification rate for logistic. No, good question, Stan. And then we'll also have AUC in 474, which is area under the ROC, AOC, AUC. Oh my God. Area under the receiver operator curve. There we go. That's what AUC is. We won't talk about that right now, but AUC is another metric we can gauge logistic regression by, which is kind of the false positive, false negative ratio, which goes into type 1, type 2 error, stat 201. So does that make sense right here? No, you're right, Snea. I mean, there's a lot to keep track, and I think a lot of people forget logistic. And logistic, what is the issue right here with this logistic curve right here? So this is the curve we're fitting to the data. This is the true relationship the data has, that the probability decreases here at the end. So this is the true model right here. Like this is the truth. This is the model we're trying to fit to it. And what do you notice here about trying to fit a logistic curve to this? The logistic curve must be what? Hint, favorite band. So people in 320 will know when I talk about their favorite band, the logistic curve is always this. And so that's a problem when you try to fit it to this data right here. Because exactly. You're hitting upon it. There's the polynomial relationship to the truth, which is non-monotonic right there. And our sigmoidal curve is an S shape, which is monotonic. So we're just using slightly different words, but everything you've said there is 100% accurate. Like you wouldn't have to say exactly, it's a non-monotonic relationship, goes in more than one direction. And you're saying that by polynomial nature of the curve wouldn't fit a sigmoidal curve. Exactly. So yeah, it's 100 points right there. Let's throw out some more points. We're just going crazy on the points. But yeah, like if I said explain this to me, I'd be like A+ answer right there. You don't have to say monotonic because everything you said is like polynomial, sigmoidal curve, shows me you understand the concepts. So great job right there. Sigmoidal fit is not good for a polynomial truth. There we go. Let's hop over to Ella's questions. Thank you so much, Ella, for waiting. Let's go back here to Ella's question. Here we go. Okay. I always try to divide time up evenly. It's tough. I'm like, okay, even time between 320 to 01. Next semester, I've got like more classes. Well, you did it perfectly. You used a word that helped out right there. So let's go for the easiest things on here. The easiest things to calculate right now are going to be the greater than p-value. So the greater than p-value right here will be what to the less than p-value? So these two right here, when you add them up, must add up to what? So the greater than and the less than, here's what they look like then. Oh my God, we just blipped. So we should be good now. I don't know. It's going to be very interesting. I'm pretty sure next fall I'm teaching 4 different types of classes. Oh, I might literally make like a 201 and I might, yeah. Good, yeah. No, I saw it on my end. We had a stream disconnect, which is weird. So what do the less than and greater than p-value add up to? And then you are correct, Ella. You've got here the two-sided. So the less than and the greater than will add up to 1. So if we were to get the greater than p-value, so what would you do to get the greater? Like, so if you have the less than is this right here. So the greater than will be what? Like the less than and the greater than must add up to 1. So the greater than must be what? So if we were to find the greater than p-value, what would you do? You would just take 1 minus it. So let's do 1 minus this right here, and we get that right there. Does that make sense, Ella? Yep. So that's the greater than p-value. So there's the greater than. And then we have the two-tailed. So think about the two-tailed right here. When we do the two-tailed p-value right here, that's just going to be double. There's the 30-minute warning for class. That's going to be double the smaller one. So whatever's the smaller one, you just do 2 times it. So that's going to be the two-tailed right there. So the two-tailed is the does not equals test. Let's make that clear also, that when we do these, we're talking about this right here being the does not equals alternative. This is the greater than alternative, and this is the less than. A little bit confusing because this one right here doesn't show does not equals, but that's the does not equals. So 95% confidence will be... Oh, so this has nothing... So here's a good point. This right here has nothing to do... I mean, you can use it for the test, but it has nothing to do with these over here. It has nothing to do with these over there. So 95% confidence will have nothing to do with the amount we shade. It'll just have to do... So it's almost like these are 2 separate sides to the output, even though the degrees of freedom is for both sides. This 95% confidence has nothing to do with this side over here. So you won't use this right here to calculate these values over here on the other side. So for the moment, we won't look at that. Does that make sense? It does mean when we make the confidence interval, we can look at a test with a 0.05 alpha level. We can use the confidence interval at a 0.05 alpha level test. So it does mean that, but you won't use that 95% confidence to get these p-values. Just the alpha, exactly. The respective confidence interval up here will have a 0.05 alpha. So it does mean that when you look at this confidence interval right here, the confidence interval can be done at a 0.05 alpha level for a two-tailed test. So that is what it can be used for. So the 95% confidence interval means that we can run the two-tailed test at a 0.05 alpha, and you'll see that here in a moment on this test. So what would be this p-value right here? Because it's going to be 2 times the smaller. Like, here's the smaller one. Here's the two-tailed. So the p-value we're looking for is this, but we only currently have this p-value. So what would, and You've already put it in the chat. I'll let you re-put it in the chat. And if you're watching right now, pause, see if you can find it. We basically have all the mathematics right here, and we have the visuals showing us that this is the p-value right here, and then the p-value we are looking for is going to be this right here, which is this right here, exactly. So Ella's figured that one out. Great practice right there. There is the p-value right there, and we're just practicing, see if we can get these answers. Now, the t-ratio, we're switching sides right now. We could talk about how we fail to reject the null right here. Good thing to note, at the 0.05 level, we fail to reject the null on the two-tailed test. Let's remove all this right here. And let's talk about the other side of the graphic. When it comes to the other side of the graphic, sure, we'll let that go away for now. The difference right here is the difference between the sample means. So what day had more demand? This is a good question right here. What day had more demand, or what days had more demand? Rain or no rain? The y variable of interest here was demand, which is a quantitative y variable because we're analyzing the means for two groups. So which group had more demand? And a good way to help remember this is to do big number minus small number. Let's say we were to take 3,000 minus 5,000, like the hypothetical mean is 3,000, the hypothetical mean is 5,000. What would that equal? Or if we did 5,000 minus 3,000. So which of these looks to be the way it is? The no rain. If you notice right here, if we have the big number second, we get a negative. And that tells us right here that the second one, if the check is not available, it just means we can't do it. It just means, so it's NA, Seth. It's a good question right there. That just means no check regression was possible. So you could just say like, cannot run check regression. I think you're talking about for the naive model. So good question right there, Seth. I would just say, can't do a check regression. Good question. So we know that the second mean was higher. And in our sample, so let's write this out. I'm going to write it out in words, because words are good. In our sample, we observed days with no rain having a higher mean by 1708.50 than days with rain. So just a good interpretation right there of the difference. Since the difference is negative, that means that the second mean in the sample was higher. So now the standard error of the difference is, I'm going to put a little line right here dividing them. I'll be very important in a second. So the standard error of the difference is, and we won't always have the equation for this, we won't always have to do it, s sub 1 squared over n sub 1 plus s sub 2. Oh my gosh, I'm going to zoom in. Someone's like, Brian, I can't read that. And I'm like, I know, I can't read it either. There we go. S sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. So Ella, if you notice out, what does this solve out for? When you take the difference and you standardize it, what do you get when you get the difference standardized right here? Like if you take the difference and standardize it, like if I divide these two numbers, go ahead and do that right now. Divide these two numbers and see what you get. Almost like A divided by B is equal to what? So what do you get if you divide those numbers right there? You get the t-ratio, which is the test statistic. So if you take 17 negative, so we'll take negative. So if you were to take 17.80.5 and do the negative of it, and 861.8, you get this right here, and we can confirm that that is the test statistic. Jump might carry some more decimals. Yep. So you just found the t-ratio, which is the test statistic. And then the upper and the lower is going to be the hardest one to solve. So this is where, and I've seen students have this be the one question they miss on the test. So we've talked about these numbers up here, how they have this ratio. So understand that ratio, that it's this divided by this is this. So if you're missing any one of these, you could solve for it. The hardest thing to solve, I think a lot of times, is going to be this down here. Let's draw this out. This is the hardest one to solve, I would say. If I blank that, I've had students say there's no way to solve that, and I'll say, there is. And they'll be like, no, you need the formula. And I'm like, no, you can solve it, I swear. So the difference is the center of the interval. And then this is a margin of error right here. So with this right here, what is at the center of our interval right now, Ella? What is at the center of our interval? I think the hard part about this is it's a two-step problem. There's no, like, you don't just solve one thing. You have to find something, then use it to find something else. So it's a multi-step problem, which I think makes it a lot more difficult. It's like, ooh, got to solve a few things right here. So at the center of our interval is going to be negative 1 point, or, yep, exactly. It's not a point. Oh my gosh. I have tried to update Microsoft Word. I reinstalled it, and it didn't change anything. So now we've got the lower of our interval. So what do you think I can find right now, Ella? So looking at this visually right here, what could I then find? And then the step to find the other number should be pretty apparent. So with what I've drawn out right here, we have the center of the interval, which is the difference, because we're going to go the difference plus or minus. We're kind of using right now the equation of y bar plus or minus t with degrees of freedom, and then standard error of y bar 1 minus y bar 2. This is the margin of error. Oh, wait. Something was wrong. There we go. This is the center. This is the margin of error. Hence the plus or minus. There we go. 13.3333. Oh, you think you might have found the answer? Great job, Ella. Yeah, I was like, wait, what? Ella might have just found the answer. Oh, close answer, Ella. So I thought you had it. I was like, it's really close. But good guess right there. Good work. Let's see right here. You might just miscarried a decimal. What do you think I'm going to solve for right now, Ella, with these numbers? What do you think I'm going to solve for using these numbers right here? I'm going to solve for the what right now? Like, using these numbers, I can use what we have on the screen right now to solve for the what. Like I said, this is probably one of the hardest problems. I've seen people make 98s on the test. Jensen, so good to see you. Thank you for swinging by. Jensen, we're going to have a huge mega Kahoot. I think we'll do it this Sunday, Mega Kahoot. Yes, you got it. I'm trying to think. Yeah, I think you did everything. I think you might have just had a math error. So let's see where the math error is. We can just take the difference as a positive numbers. It works that way. Okay, there we go. There's the difference. And then we're going to take and we're going to add it to this right here. So that's the margin of error. We now know 1969.3. Tell everyone, especially in the group me's and stuff, $50 Kahoot. $50 Kahoot. $50 Kahoot. No. Gosh, I hope we don't have lag during the Kahoot. YouTube's been pretty laggy today, which is going to be fun during class. Yay. So now all we're doing is going to take and add this to this. So we can subtract. Okay, almost right. Okay, here we go. We're going to add it to it. So 1780.50 minus plus. There we go. And there it is right there. Oh my God, what? The Kahoot? The Mega Kahoot? Tell everyone in the group me. Mega Kahoot this Sunday. I'll send out announcements about it. Yes. $50 grand prize, $20 second prize, $10 third prize. I thank you to everyone who watches the channel. And okay, so that's just a decimal difference from how they're carrying decimals in the background. Yeah, that would be perfectly fine. I know someone's gonna win. I'm excited. I really have a lot of fun doing them. Have Tiny Brian do the announcements.
Why do I always get announced the Kahoots? My voice sounds weird.
I like Tiny Brian. Great job right there, Ella. Good to see you, Jensen. Let's put a little relaxing music on right here. My favorite relaxing music. It's funny, I hear it louder than everyone. Well, so Jensen, we're having 201 right, 320 right now. I was about to say we're about to do a review, but we'll be reviewing a little bit later for 201. You're welcome, Ella. Great questions today, Ella. Looks like you're getting prepared for the final. We'll be reviewing today in 201. I'll send out announcements to all my sections. If you happen, Jensen, if you want, email me at bstevens@utk.edu. If you're on a UTK email, I'll send you the email. I'll try to check it. You're welcome, Caroline. So I'll be sending out announcements to everybody in 201. Let me send out the 320 announcement to say. Let me do that while we're talking right here. While we're talking, it's the last day, and we're gonna be reviewing. Watch class live. So I'll send this out to all 201 sections when their class starts at 4:30. Reviewing for final. Already got the thing marked. 17 minutes. Okay, announcement. So if you're in any of my 201 sections, you will get an announcement today, like reviewing for final. And that starts at 4:30. Reviewing for final. Hey everyone, feel free to join today's class and review for the final. There we go. Click here. Okay. There we go. Send announcement. Reviewing for final. Let's go. Time to review. Okay. There we go. ... in 17 minutes. Okay. Let's do that. I think that's got it. We're good to go. What does Snea say? Brian, reference to when Colin came in earlier. I'm looking at jobs. What? Are you Snea? That's all. You should have said that. I mean, like, I'm like, Colin is he's such an amazing guy. Like, he really cares about students. He started a club called UT Know. So if you've heard about UT Know, where he wants to connect students to businesses, and he has people from Disney come in and speak. And Colin did an internship at Disney and really wants to work at Disney. Like, Colin is like, he wore his Disney name tag around UT because he's all about the Disney brand and all about like the positivity that Disney brings. Because they're really, from what I've seen from Disney as a company, they're very much like, they're just a very positive company, and I love that. Like, I don't know, I've never worked for them, but I know a lot of students who have, and they're like, yeah, Disney treats us really well. And I like hearing that. I like hearing that companies treat people really well. And it's because Colin's like, I got a virtual internship with a marketing and advertising industry for the summer, so I'd like to work in the media and entertainment industry. Yes, Snea, you're doing everything right. And you know, if you ever need a recommendation, I'll say how you've been one of our top students. Like, I love giving recommendations, and you know, the more, it's too sad of music. The more, you know, people are here, they're interacting, you know, turning in great work and everything, it's easy to give recommendations, even in the virtual environment. But, you know, next time you see Colin, feel free to tell him that. It's your call. But, you know, it's all about, I think people will tell you this, like, people will agree. It's all about putting yourself out there, meeting people, making connections, because, like, gosh, I hate to think I'd time travel and do this. You got it. Don't worry. You're doing fine. You're great job on your internship and everything. Like, congratulations, because you're doing everything. Like, it was 9 years, 3 days ago. Maybe it was a little bit longer because I think we celebrate our first time. Rumi from last year is like the biggest Nizzy fan, but she can't get to do the college program because she lives in Scotland. If she gets the international student position at some point, I hope so too, Jensen. I really do. And just keep telling her to keep trying, because a lot of these programs, they notice when people keep applying. So like, Necro's like, Snea, you've joined in our Among Us. Don't worry, like, you're doing great at it. You're doing great at networking, because it's just taking chances and just putting yourself out there. And you know, it was like over 9 years ago, I went to an event called Headphone Disco. And there was this girl who was sitting on the like the area in what is it called, presidential? I'm totally messing up the story. She was just sitting over to the side, and I was like, hi, and she was like, hi, and I was like, I don't even know what I said first. I don't even know, but somehow we got talking about video games. We got talking about just like Mario Kart. We got talking about Pokemon, and to this day, I still play video games with that girl. I'm still, you know, hanging out with her, playing video games. We live together, you know, and it's just, yeah. Well, Jensen, you'll have to join in our Among Us games. And had I not just walked up to that girl, just think about how one thing can change your life. Makes me sad to think, like, what if that night I'd just been like, I don't want to go out. Like, if that night I had not gone out, my whole life would be different. And I fear to think, because she's inspired me in so many ways. Not joking, she's the reason I started YouTube. She watched so much more YouTube than me back in the day, which is so funny because I'm all YouTube now. Like, she's just like, you're obsessed with YouTube. And I'm like, you're the one who started it. But she was like, she was into YouTube, into YouTubers, like, like, just like, she treated it like it was TV. She's just like, well, I've got YouTube. I don't need TV. I've got all these YouTube people who make videos. And she had been doing, YouTube started in like 06, and she'd been watching it since like 09. She was one of the earlier people watching YouTube, and not just like going to it to like watch random things, but like subscribing to YouTubers and everything. So I was like, I should make a YouTube channel. And that's how it all started. That's how this whole channel got started. So yeah, you're doing fine. You got it, Snea. I'm very impressed with my students, and I'm proud of them. Super nervous about the intro because it's with UT Study Abroad, so the company's based in Portugal. I bet you'll do great. Just what companies look for is somebody who's just positive, willing to learn, and has skills. Like, and really a lot of it's attitude. Companies much rather have people who are willing to learn, and those are the people they want in their company, because if you're going to spend like 8, 9, 10 hours a day working, you want to be around people who are going to lift you up and help you out. And I'm really glad, like, my department and everything has so many amazing people. Like, I just like going to department meetings because I'll be like, oh, I haven't seen so-and-so in a long time. And that's when you know you're working for a great company right there. So, keep up the positivity. Snea, you're doing great. Very proud of you. Jensen, great to see you here. Like, I don't know Jensen as well, but no, Jensen, thank you for always coming by. When we're streaming, we're doing contests. I don't know. I just think people, it's my last thing to say. I totally agree. Yeah, I applied for a competition, so it is with Deloitte, to put myself out there. And I have an intern. Caroline, I can't top that. And I mean that in a good way. That's exactly what we're talking about. You just put yourself out there, and then it changes the course of history. Don't worry. Like, I mean, how many times did I go out and not meet my fiance? How many times did Brian say, I'm going to go out somewhere tonight, and it was just a whatever night? How many times you in a contest and you don't win, or you apply for an internship, you don't get it? You don't remember those times. You don't remember the times you fail, because there's a lot of failure before success. You sound like it's one of those trite inspirational things, but it's so true. Just put yourself out there. Exactly, Caroline. Caroline, you know what? We're going to end with that, because Caroline, that is the message I want to send. Put yourself out there, and amazing things can happen. They might not always, but keep trying. Keep trying. So you got it, everyone. Stay strong. 3:20, I'll be seeing you soon. I'm going to go get some awake chocolate and wake up some more. Brian runs on caffeine. Bye for now, everyone. Bye! Congratulations, Caroline and Snea and Jensen.